Welcome to today's Coffee Break webinar. ZOHO Tribology Solutions provide value-added services in lubrication and reliability. We are India's only comprehensive lubrication services company. Lubrication Institute is a division of ZOHO Tribology Solutions. We are one of the leading companies providing training on oil analysis, machinery lubrication and equipment reliability. We have trained several industries professionals from leading companies throughout Asia. We are official training partners of ICML and Noria, USA, world's foremost company in lubrication. Let me introduce you to our speaker Mr. KNV Subramaniam. Our speaker is an ICML certified professional and has a rich industry experience. Thank you, and over to KNV sir.
Hey, good afternoon, everyone. The idea of this coffee break webinar sessions is to give you a small important thoughts, especially the lubrication related reliability. So today's topic is about the contamination control, how it builds the reliable operation of your equipment. So fluid contamination control targets the primary cause of wear and the lubricant failure. So therefore, this is the central strategy, or you can say the proactive maintenance approach to control all the contaminants, thereby keeping a clean lubricant to enable it to provide a proper lubrication, and that is going to last for a longer time and protect your components from the wear, friction, and all the other the possible impacts, right? So what do we call them as contaminants? Particles, moisture, fuel contaminations, coolant contaminations, even the heat, radiation. So these are also considered as contaminations. Even the other lubricants which are mixed with your, the existing ones, that is also a contaminant, which is again, leads to incompatibility of the lubricants and creating a physical and chemical characteristics differences in the lubricants, right? So how these contaminants can damage your lubrication and machine components, right? So although we have noticed various contaminations are there, you could see water is the most common contaminant. Again, particles too. Particles are also the most common contaminants, which comes from the environment, which comes from the operational related things, process related contamination. So all these will continue to add up to your lubricants and making the lubricants changes in its physical chemical properties, and therefore some the further changes will take place, right? So take a simple example of a water contamination. So water contamination leads your lubricant to an oxidation state. That means water reacts with your antioxidant additives, depletes the antioxidant additives very quickly, and make your base oil to get oxidized rapidly. The moment oil gets oxidized, what happens? Your oil's viscosity will increase, emulsions will form, sludge contents will form. All these things will allow your lubricant viscosity to increase from its original level. So therefore, what happens? The increased viscous film may not reach the contacts properly in time, and leading to a drag in the viscous drag in the lubrication, and components will come and wear and tear will take place, and internal frictions will also get increased, right? So not only that, the moment oxidation started, there is a rapid increase in the acidic formations because of the additives depletion, and water contamination directly leads to rusting of your machine surfaces. Free water contamination can potentially lead to cavitation problems, scuffing related issues in the component surfaces. If you observe all of these contaminants, a few contaminants which are listed out here, every contamination is driving your lubricant to get oxidized. Either it is making your lubricant to lose its additives rapidly, and thereby leading the lubricant base oil to become oxidized. The moment it becomes oxidized, all the changes in physical properties you will see, changes in chemical properties you will see, and also has a direct indirect effect on the machine components as well. This is the reason why we need to control the contamination, and that is going to form the central strategy of our reliable maintenance. Okay. So let us observe a case study from Nippon Steel Corporation, so which is one of the very renowned steel company in Japan. They had a very huge failures at one point of time. They were having more number of failures and they could identify them more. Many of those failures are connected with the contamination related problems. So they've made an action plan to set up a cleanliness targets for every type of equipment. They provided sampling ports for proper collection of an oil sample for further analysis. They improved the existing filters and breathers, and they bought an on-site particle counter for understanding the particle counts on a live manner. Initially, if you see this particular action plan as it was progressing, you could see there are some hiccups. Sometimes you can see there is a decrease in the failures, but there is a sudden steep increase in the failures, but they have not stopped. They continue to follow this program. As the program is evolving over a period of time, you could see the tremendous changes. The failures are constantly reduced, and now that in a period of 5 years period of their monitoring, the failures have reduced almost from 80% of the failures. They could have potentially reduced it to almost close to 20%. Not only that, 75% reduction in the oil consumption they have achieved during this time. 80% reduction in the hydraulic repairs because the lubricant is clean. A clean lubricant provides a proper lubrication to the component surfaces. Therefore, the wear and tear will be expected to be very minimum or normal in its range. And also, there is a tremendous reduction in the bearing purchases as well. That means your number of failures have come down, so there is no more need of purchasing more bearings and then keep it as an inventory in your storeroom. Another case study from Kawasaki Steel, the pre-contamination levels 100%, fluid consumption levels and breakdown percentage 100%. Once they started an action plan just similar to the Nippon Steel, cleanliness targets, installed an off-time filters, and on-site particle counts to measure and confirm that they're maintaining the systems at a proper cleanliness levels. In a period of 5 years, you can see in the year 2 itself, you can see 57% reduction of fluid consumption and 75% reduction in the breakdown frequency. And over a period of 5 years, they could achieve only 20% of the fluid consumption with respect to what it was 100% 5 years ago, and only 4% of a breakdown frequency. Right? So there is absolutely no rocket science here. The ultimate objective of a contamination control is to make your oil free from all contaminations. A lubricant, with whatever way it was being produced, it has to be there in your system, right? Now, another interesting case study from National Research Council of Canada. What actually drives your machine components to go fail? Is it a particle-based contamination or a non-particle-based contamination? This study was conducted in about 4,000 different equipments from different industrial sectors like pulp and paper, forestry, mining, agriculture, power generation, manufacturing, various industries. They found 82% of the failures are related to the contamination, which is again related or connected with the particles contamination. 18% are non-particles based contamination, which could be because of a improper oil usage, which could be because of lubricant degradation in service, which could be some byproducts, the chemical byproducts which were generated as a resultant of lubrication related issues. So what makes your machine to go fail? Particles. Particles are the major concern which can drive your machine or components to the failure mode, right? So particles contamination is what we can always consider as a cause and effect of wear. They cause the machine components to generate the wear, and they are also again the effect of these particles, the wear rate, the wear generation or wear particles that are generated. They are again contributing to the secondary wear out of your components, right? Like some failure inducing particles like brushing particles, erosion particles, surface fatigue related wear and tear, denting related particles and all, they continue to be, running along with your oil, and they continue to again gouge the surfaces, scratch the surfaces, and further generates more and more amount of, subsequent wear again. So therefore, what is happening? Particles contamination is the root cause of, the components failure, and the effect of, this root cause is also again contributed by the amount of particles there. So predictive maintenance approach always looks at, removing these particles. Predictive maintenance approach, the moment we find a NAS value or an ISO contamination cleanliness levels were high, then we always look for a solution to remove the particles. But if you practice a proactive maintenance approach, we will always look for the sources of, where these contaminations are coming from, and then we start working on, controlling the contaminations, getting into the system. So if you practice this proactive maintenance, this builds your central strategy for improving the reliability through the contamination control, right? So this is actually confirmed by even GE, Mobil, Shell, various manufacturers like Flender, Siemens. You've got various case studies on the contamination.
If you really want to take a deep dive into the world of industrial lubricants, machinery lubrication, contamination control, oil analysis, and much more, join us in our upcoming trainings. Our next training on Machinery Lubrication Level 1 is scheduled from 7th to February 9th, 2023. This will be live online, and you will be able to clarify all your doubts with the trainer during the training. This 3-day extensive training prepares you for ICML certification. Investment for this training for Indian residents is 39,000 rupees, inclusive of GST. However, for participants who have attended the coffee break webinar and register within 24 hours from now, you have a special deal. The training charges will be 35,100 rupees, including GST. The payment link is available on Q&A. The link will also be shared via email on webinar completion. You will also get a copy of Lubrication Engineer's Handbook immediately on registering for the training program. You can write to us at info@lubrication-institute.com for your suggestions on topics that you want us to cover in upcoming webinars.
So good evening, everyone. Let me take some questions from the participants. There is a question from Mr. Kunal Verma from India. And then he is asking, what are the best contamination control practices? See, Kunal, the best contamination control practices as per the world-class best standards are concerned, it's very simple. There are two things. One is contaminant exclusion and contaminant removal process. See, the contamination exclusion process involves understanding where the contaminants are, entering into your system. Find out all the root causes or root sources, you can say, wherever the contaminations are entering, be it a moist environment, or you can say a sort of seals failure or damaged seals, steam leakages into the system. So try to avoid or arrest all the possible entries of the contaminations into your system. That will be the best strategy considered to be the best contamination control practice. Secondly, the other process is the contamination removal process. Once you know there are certain contaminants, be it some particles or moisture, or you can say air contaminations, you have to take immediate actions to remove the things very immediately, right? So these are the best contamination control practices. Okay, these are some of the questions. There are many other questions are there which will definitely try to answer you, personally to your email IDs.